Okay, 2.3, we are going to be solving equations using substitution, solving systems of equations using substitution. In order to do that, we need to know how to solve multi-step equations as well as two-step equations. So going to go over just solving two-step equations, and then we'll look at some multi-step equations, and then we'll move into solving systems of equations. And today we're going to be solving for both the x and the y variable. In number 1, we are looking to get v by itself. It's currently being subtracted by 4. So I'm going to make a little note here that this is subtracting. You don't have to write this, but I do want to just note that 4 is subtracting. And then we also have this 6, which I'll make green here. And that 6 is multiplying with v. So in terms of what they are trying to, or how they are affecting the variable in red here, 6 is multiplying with it and the 4 is subtracting to it. So we need to get the variable by itself, which means that we need to move both the 6 and the 4. We get rid of whatever is adding or subtracting first. So here I have 4 is subtracting. So I'm going to do the inverse, or the opposite operation, and add it to both sides. So when I add 4 to both sides, this cancels it all out. There's no more 4 on this side. So now I'm just left with 6 times v equals, and then I'll work out 8 plus 4 to get 12. So 6 times v equals 12. And remember we said earlier that 6 was multiplying. So when 6 is multiplying with v, the inverse, or the opposite of multiplying, is to divide. So we undo multiplication with division. So when I undo that, I'm left with v equals, and then 12 divided by 6, which will give us 2. So v equals 2. In number 2, we're doing the same thing. I will color coordinate some things here. We need x by itself, that's the variable. We need to get rid of this plus 4, that's adding. So that's adding to the x. And we also need to get rid of this negative 4, which is multiplying. So remember, we always get rid of whatever is adding or subtracting first. So in this case, I'm going to get rid of that plus 4, and I get rid of a plus 4 by doing the opposite. So I'm subtracting 4 to both sides. Those cancel each other out, so that negative 4x, that's what I had in green and red, equals negative 28. Signs were the same. Add them and keep the sign. Now to get x by itself, I need to divide negative 4 to both sides. Negative 4 was multiplying with x, so I am dividing it. Those cancel each other out to give us 1x is equal to negative 28 divided by negative 4, which is a positive 7. Okay, in number 3, this is what many of our substitution problems are actually going to look like. We will have two-step equations once we work these down. But the first thing we need to do is we need to take this negative 5 and distribute it in to multiply with the quantity negative 3 plus 3r. So when I multiply that in, I'm going to work from left to right. Negative 4r doesn't change, so I'm just going to rewrite that. And then make that look like an r. And then in red here, negative 5 times negative 3, negative 5 times negative 3 is going to give me a positive 15. And negative 5 times positive 3r is going to give me negative 15r. And then I'm still setting that equal to 72. So in red, that's what I got when I distributed negative 5. The next thing I'm looking to do is combine like terms that are on the same side of the equation. So on this side of the equation, we have like terms of negative 15r and negative 4r, which when I combine those, I get negative 19r. And I can write that either first or second. I'm going to move that over here and write it first. So let's see, I used negative 4 and negative 15 to make negative 19, which means that this positive 15 still needs to get written down here. Okay, now I'm ready to solve a two-step equation, just like we did in numbers 1 and 2. So I'm subtracting 15 to both sides first, so that negative 19r is equal to 72 minus 15, which is going to give us 57. I am now going to divide negative 19 to both sides because it was multiplying. I divide to find that r is equal to negative, and we do 57 divided by 19, and it's going to give us 3. Our signs were different, so we got a negative. All right, and then in number 4, we have this negative 5. So this negative sign is attached to the 5, and it is multiplying in with 1 plus 3n. So this 3n doesn't change. In red here, negative 5 times 1 is negative 5, and negative 5 times 3n is negative 15n. And that equals negative 65. The next thing I'm looking to do is combine like terms. I have a negative 15n and a positive 3n. Signs are different, so I'll subtract them and be left with negative 12n. So when I put these two together, they made negative 12n. I still have a negative 5, and then that equals negative 65. And now I have a two-step equation where I can add 5 to both sides first, so that negative 12n equals negative 60. And then I'm dividing negative 12 to both sides, so that n equals positive 5. 60 divided by 12. The calculation part you could do in a calculator. Any of the adding, subtracting, multiplying, dividing. The process is what I want you to see. Okay, and then very quickly I'm going to solve each of these by graphing. Just a reminder of how to graph so that we don't forget it, because it is one of the few ways, one of the 3 ways that we can solve systems of equations. We like to graph when both equations are written in slope-intercept form. If they're not both written in slope-intercept form, it's not as easy to graph. But these, we can look for my red equation. My b is negative 1, and I'm moving down 1, right 2. That's my slope. Down 1, right 2. Can also count up 1, left 2. If you don't remember this, you may want to go back and watch through Unit 1. This was all Unit 1 stuff. For my blue equation, we're beginning at positive 1, and we're counting down 3, right 2, down 3, right 2. We could also go the opposite direction, but we don't really need to because we have points that overlap. And our overlapping points, which I'll show, are red and blue overlap to make purple. And that point is our solution. So that is the x value and y value that if we were to take it and plug in x and y there and x and y there, we would get true statements. It would satisfy both equations. And so our x value, so here's my point. So if I drew a line, my x value is 2, and my y value, if I take my point and draw a line through my point, is negative 2. So there's my x and my y. Okay, again with number 6. Start with red. begin at 4 and count down 3. 1, 2, 3, right 2. 1, 2, 3, right 2. Can't really do another one. Okay. For my blue equation, I'm beginning at -4. And I can count up 5, right 2. 1, 2, 3, 4. Right 2, somewhere out there. And I just did that one to help me make a better line. And then the purple is where our points intersect, or where they cross, and that tells us our answer. So we describe our answer as our x value. So here's my x value. So the x is 2, and the y is 1. All right, we're going to solve each system by substitution, and we are solving for both x and y. So if you watch the way I organize my work, this is like a pretty nice way to keep track of everything. And it's similar to what I've been doing before. So we know that y equals 4x plus 2, so I'm going to replace it in here. So I'm going to say 4x minus 3, and then I'm going to replace the y with 4x plus 2. And then I'm going to say equals 10. So now, just like we did in the warm-up, or at the beginning of this, I need to distribute 3 times 4x and 3 times 2. So I have 4x, because that didn't change, and then 3 times -3 times 4x is -12x. -3 times 2 is -6 equals 10. Then we combine like terms, which would be, I'll show you in blue, this 4x and this -12x. I can combine those to get -8x minus 6 equals 10. And then we are solving a two-step equation. So I'm adding 6 to both sides first, so that -8x equals 16. And then I'm dividing -8 to both sides. So that x equals -2. All right. We do know that x equals -2 now. Now, what does that tell us? Well, in our ordered pair of x and y, we have our x value of -2. But we still need to find our y value. So we are going to do another substitution problem. But this time, I'm going to take the answer that I found, which I'll highlight in purple. So this answer that I found of x equals 2, and I'm going to plug it in. And I can plug it into either equation. So I'm going to take this, and I could plug it in here. I could also plug it in for this equation. I'm not sure which one looks easier to you, but I know which one is easier. And because I'm lazy, I like to do the one that's less work, which is going to be the one where y is already solved for. So if I were to take y equals 4x plus 2, and I guess you wouldn't really have to write the x in here. You could substitute it. But now, instead of x, and I'll highlight this in purple, instead of x, I'm using the value that I found, -2. So y equals 4, just stick with purple here, times -2. That's not 4 minus 2, that's 4 times. Same way this says 4 times x, so we're going to say 4 times whatever our value is for x, and then -2. And now I can solve this. So y equals 4 times -2 is -8. And -8 minus 2 is -10. So 2 comma negative 10. All right, let's see a couple more of these. So our first step is to substitute. Do that in purple again. We take our value for y and we substitute it into the other equation. So minus 6 times, do that in red, negative 3 plus 3x plus 2 equals 10. Okay, so now we distribute, not purple, I'll use blue. So I'm taking negative 6 times negative 3x to get positive 18x, negative 6 times 2 to get negative 12. 4x didn't change, and that still equals 10. Now we combine like terms. So 4x plus 18x is 22x minus 12 equals 10. Now we have a two-step equation, so I'm adding 12 to both sides. So the numbers change, but the process is the same, and that's why it's really important to see this several times, often and repetitive, is because it helps us understand the process. We don't necessarily want to memorize what the numbers are. We just want to know what the numbers are doing, and then we can apply it to anything, to any set of numbers. So x equals 1 here. So we found what x equals, which means I can use that in x for either this equation or this equation. And the one where y is solved for is going to be the easiest. Y equals negative 3 times 1 plus 2. So now I'm just solving this out. Y equals negative 3 times 1, which is negative 3 plus 2. And negative 3 plus 2 is negative 1. So I found that y equals negative 1. So I write my answer as an ordered pair. My x value, which was 1, comma my y value, which was negative 1. All right, let's just do a couple more of these. Again, repetition builds fluency. The more we see it, the more comfortable we should be with it. So I'm going to substitute. So I have negative 6x minus 3, and then I'm replacing y with negative 6x minus 9. And then I finish writing out my equation equals 3. I guess I wanted a red parenthesis there. Okay, so once I've substituted, then I can just focus on this problem. Taking negative 3 and multiplying it with negative 6 to get positive 18x. Negative 3 times negative 9 to get positive 27. I'm going to rewrite the rest of my equation. So I had a negative 6x over here. I have equals 3 over here. So my like terms, which is negative 16x and positive 18x, I can combine those to get positive 12x. So it's 18 minus 6. Rewrite everything. Now my two-step equation, I'm subtracting 27 to both sides. So that 12x equals negative 24. I can divide 12 to both sides. So that x equals negative 2. So we found what our x is. We need to take that information. So x equals negative 2. We're going to take that information and plug it in for x in either equation, but it's easier in the one that y is solved for. So in that case, it's our second one. Y equals negative 6, and then instead of x, I can replace it with a negative 2. So the second half of substitution is pretty easy. Then it's not quite as big of an equation. Y equals negative 6 times negative 2 is positive 12 minus 9. And then when we do 12 minus 9, we get 3. And then we write this as our x value, which was negative 2, comma, our y value, which is positive 3. All right. Let's take a look at number 10. Number 10, we have 3x plus 11, and we are replacing that for x in this top equation. So we have 4, and then we're replacing, oh, nope. See, you have to be very careful, and this is something that I started to do because if you start doing a lot of them, you stop paying attention, and I'm trying to talk while I'm doing this. If I were to do this, I would be sending my substitute to the wrong classroom. This substitute has to go to the Y classroom. So I made a mistake. The most important part of this math is not doing it perfectly or not making mistakes. The most important part is catching mistakes. So I'm going to replace y with 3x plus 11 and then equals 17. I can distribute, so 5 times 3 is 15x. Keep that in blue actually. And 5 times 11 is 55. And then I've got to rewrite. I have a 4x here. And I also have 17 here. Okay. Like terms, 4x and 15x, they're both positive, so we just add them up to get 19x plus 55 equals 17. Now I can subtract 55 from both sides. Those cancel out. And in case you needed to see the line there. So I'm left with 19x on this side equals, I'm doing 17 minus 55. And that's going to give us a negative 38. Negative 38. So now I can divide 19 to both sides to get x by itself. And we find that x is equal to negative 38 divided by 19. Negative divided by positive, signs are different. We'll get a negative and 2. 38 divided by 19 is 2. So x is negative 2. We're only part way done. We've only found half of our answer, right? When we're writing as an ordered pair, we have our x, comma, our y. And we don't know what our y is yet, but we're about to. So we're going to plug that in. I'm going to use the bottom equation here. Y equals 3 times negative 2 plus 11. So y equals negative 6 plus 11. Y equals 5. X is negative 2, y is 5. You could, and I guess I'll show you this just down below. If we were to take our top equation of 4x plus 5y equals 17, and we plugged x in on this equation, now this is something you don't have to do, but I want you to see. It is a little bit more work, so we're doing 4 times negative 2, which is negative 8, plus 5y equals 17. Then we have to add 8 to both sides. So that 5y equals 25. 17 plus 8 is 25. And then we divide 5. And y equals 5. So it doesn't matter, right? Because I got y equals 5 there, but I also got y equals 5 here. It doesn't matter which equation you choose, but if you notice, the one where y is solved for is a lot less work. That was only a couple steps. Look at all the steps here I had to do. So it's up to you, but I would suggest using this one. Okay, thank you for watching, and we will continue working with substitution as we get better and better at it and see it more and more.